Technology for a Science Class by Evan Cook, University of Arizona, May 2019, TEDV 411. My name is Evan Cook, and I intend to teach middle school science. My favorite grade, of course, is 6th grade, but I seem to have an easy time educating 8th graders too. Eventually, I see myself teaching in Las Vegas, and I believe I will make a difference by sharing my passion for science with children. Make them curious and lifelong learners. Technology is an integral part of science, though. Or perhaps it's the other way around. Science inherently calls for the use of tech, and this will be a great motivation to utilize tech standards for both students and teachers. According to Dr. Arnold, tech is a tool or idea that can improve our lives. There are many types of tech, though. Education tech is technology that helps teach ideas or concepts. Digital tech is based on binary software and is often electronic in nature. Analog tech may utilize electricity but process physical data and not electrical signals. I believe it is important to learn about inventors for the same reason we desire to know about artists. When we know who invented something, we can understand its context. Why was it made? Who made it and for what purpose? What challenges did they face? What worked? What failed? These are all important questions to ask because the answers tell us that there is more to the story than just a simple tool that was invented. This context is important when concerning maker tech. As Pépierre says, learning is most effective when part of an activity the learners experience in constructing a meaningful product. And I can easily fit inventors and their inventions into science class. Much of the information and technology we have today is a result of science. I think it would be interesting to do entire units where we not only learn science concepts, but also who discovered them. This means that we will usually use technology to help replicate experiments in the lab. Galileo developed the telescope and changed how we see the world in our solar system. Edison made the light bulb and it changed how we see at night. Tesla developed AC power and now we can use it in our homes every day. Apple developed the computer so that we can have one in our very homes. And students benefit from each of these devices every day. We use these inventions in science class to help learn more about science and show why science is important by showing its application. I can implement the study of technology by differentiating my presentation of the subject. The class can go on a field trip to an observatory and see the stars for themselves, and as well as the technology used to see them. Kitt Peak National Observatory, KPNO, part of the National Optical Astronomy Observatory, NOAO, supports the most diverse collection of astronomical observatories on Earth for nighttime optical and infrared astronomy and daytime study of the sun. Sharing the mountaintop site with the National Solar Observatory, KPNO, founded in 1958, operates 3 major nighttime telescopes and hosts the facilities of consortia which operate 22 optical telescopes and 2 radio telescopes. Kitt Peak National Observatory, 2019. I can have students build models of the planets, showing how they orbit one another within our galaxy as a way for them to apply their understanding of our solar system. And students can build their own basic robots with LEGO Mindstorms and have a presentation given by a robotics engineer from the University of Arizona. And finally, students can experience where our water comes from by visiting a water treatment plant. Some important inventors to learn about, though, would be interesting to students would be Leonardo da Vinci, the Wright brothers, Wernher von Braun, and Elon Musk. All of these inventors developed the technology that got us into space. Da Vinci gave us some of the first blueprints for flying machines. He started us down the right path to flight. The Wright brothers pushed us over that edge and got us off the ground, so to speak. Though Leonardo da Vinci may be most famous for his works at Enarsus, he actually spent quite a bit more time working on his endeavors in science and technology. Of course, his detailed sketches and distinct artistry played a large role in his inventions, and his sketchbooks later provided evidence that Da Vinci had envisioned many ideas long before the technology to build them actually existed. Da Vinci Inventions, 2008. Again, the Wright brothers pushed us over that edge and got us off the ground, so to speak. And Wilbur and Orville set to work trying to figure out how to design wings for flight. They observed that birds angled their wings for balance and control and tried to emulate this, developing a concept called wing warping. When they added a movable rudder, the Wright brothers found that they had the magic formula on December 17th, 1903. They succeeded in flying the first free-controlled flight of a power-driven, heavier-than-air plane. Wilbur flew the first plane for 59 seconds at 852 feet, an extraordinary achievement, says History.com, editors, 2009. And Wernher von Braun was the father of modern rocketry. As a former Nazi, he developed the V-2 rocket program that would eventually send us to the moon. Wernher von Braun was one of the most important rocket developers and champions of space exploration during the period between the 1930s and the 1970s. MSFC History Office, 2019. Elon Musk would take that a step further by making rockets reusable and thus making spaceflight cheaper and more accessible to humanity. Elon Musk leads space exploration technologies, where he oversees the development and manufacturing of advanced rockets and spacecraft for missions to and beyond Earth orbit. Founded in 2002, SpaceX's mission is to enable humans to become a spacefaring civilization and have multi-planet species by building a self-sustaining city on Mars. In 2008, SpaceX's Falcon 1 became the first privately developed liquid fuel launch vehicle to orbit the Earth. Following that milestone, NASA awarded SpaceX with the contracts to carry cargo and crew to the International Space Station, ISS. A global leader in commercial launch services, SpaceX is the first commercial provider to launch and recover a spacecraft from orbit, attach a commercial spacecraft to the ISS, and successfully land an orbital-class rocket booster. Space Explorations Technology Corp., 2017. As we learn about space and the standards, rockets and their inventors can give us context as to how we discovered much of what we know about space. From GPS to black hole images, rockets have greatly expanded our understanding of space and our world. A great way to integrate these concepts, as well as applying it to science class, is to have labs. Having students make rockets, building telescopes, and even paper planes can demonstrate the applications of what we learn in science class. According to the U.S. Department of Commerce, STEM occupations are growing at 17%, while other occupations are growing at 9.8%. STEM degree holders have a higher income, even in non-STEM career field. Science, technology, engineering, and mathematics workers play a key role in the sustained growth and stability of the U.S. economy, and are a critical component to helping the U.S. win the future. STEM education creates critical thinkers, increases science literacy, enables the next generation of innovators. Innovation leads to new products and processes that sustain our economy. This innovation and science literacy depends on a solid knowledge base in the STEM areas. It is clear that most jobs in the future will require basic understanding of math and science. Despite these compelling facts, mathematics and science scores are on average among U.S. students and lagging behind other developing countries. Engineering for Kids, 2019. The standards I'll be using are 6E2U1.7, using ratios and proportions to analyze and interpret data related to scales, properties, and relationships among objects in our solar system. 6P2U1.4, develop and use a model to predict how forces act on objects at a distance. These standards both relate to space technology. And the first standard allows us to use rockets to help gauge distance from one planetary object to the next. This will help illustrate scale in our solar system. The second standard allows us to see gravity, how gravity can affect rockets, such as gravitational slingshot around the moon. In fact, Wernher von Braun expected to utilize such an effect when sending astronauts to the moon, as well as satellites. The Maker Movement is about individuals who have a strong, curious personality and have a passion for do-it-yourself projects. In the past, they might have been called craftsmen or inventors. Today, anyone can be a maker with all the technology and materials around us. I believe that the Maker Movement is important because it will help educate the masses on how to engineer and build things. The Maker Movement movie suggests that we're going to see a steady advance in localized manufacturing, which means that it is important for everyone to have these skills if they are to get the things they need or contribute to the community. Making is a perfect fit for science class, as it is hands-on learning. Tinkering is a powerful form of learning by doing, says an Invent to Learn article. As a teacher that focuses on constructivism, I believe that this is an important concept in the science classroom. Labs provide the perfect opportunity to utilize maker projects. Some of my favorite projects are making simple machines, making cells, and the classic potato launcher. Physics is much easier to teach when you can demonstrate the concepts in reality with simple machines. What better way to learn such phenomena than making and playing with simple machines? And when exploring cells in biology, I think neat little project is to make your own with cell gel. It helps students know and understand the many functions of the cell. It also allows students to customize the organelles with their own materials and thus provides engagement and connection to the project. The potato launcher, however, is a great way to demonstrate many concepts such as chemistry, physics, engineering, and mathematics. There are various ways to build a potato launcher, and each utilize a different concept in science. The Maker Faire folks are an organization that help organize a Maker Faire or help you find one. They can also provide resources for major projects and ideas. Rockets are a great way to get students to connect with these performance objectives in science for both Earth and space standards and physical standards. With rocketry, a teacher could apply mathematical gravitational concepts to its trajectory, fulfilling one of the standards previously mentioned. Rocketry can also help students understand scale. When they see how fast a simple rocket can be compared to an industrial rocket, they will fully conceptualize how big space is when you tell them it can take up to 8 months to reach Mars with our fastest rockets. This would fulfill the other standard mentioned. Maker technologies can easily apply STEAM to their projects. When designing a project, math and engineering concepts are integral to making a consistent product. Art is a great way to help plan things out as well by drawing the idea beforehand. 3D printers and other technology can be used to enhance the experience as well. I want to utilize both technology and maker projects in my classroom. This will support their learning in science as they are inherent features of the curriculum. Labs, videos, and projects all are great ways to include technology and maker concepts in the classroom. I couldn't imagine my classroom without them. The Invent to Learn article agrees. Many of the same technology skills and conceptual understanding are found in the physics lab, art studio, and auto shop. There are many benefits to implementing these concepts in the classroom. Synthesis of the best available evidence consistently indicate the potential for positive effects when tech is a key ingredient in well-designed learning systems. Learning effectiveness, tech.edu.gov. Technology can also make things easier by taking the manual labor out of certain aspects of projects. Using a computer to search for data is much easier than reading through a long book, for instance. Unfortunately, it also has its disadvantages. Students may become too reliant on technology. For instance, do you know how to find the square root of a complex number? I doubt you could because we have become so reliant on calculators. Screens can be very valuable in science class. Yet the real world is where we live, and it's important to see things for ourselves. That's why it's important to balance our virtual world with our real one. Some ideas are just too abstract in science to just be told or shown how they work. Sometimes students need to feel, hear, and smell the lesson to understand it. I can integrate this into the daily curriculum because making gives us opportunities. It engages students and motivates them while providing a personal connection to the lesson. And as I've said before, labs, videos, and projects are all great ways to implement maker skills and technology in the classroom on a daily basis. When it comes to science, there are too many resources to list. YouTube shows like Veritasium, Crash Course, SciShow, and Action Lab all provide great ways to visualize certain scientific concepts that can't be replicated in a classroom due to safety or expensive materials. Physics Grow, King of Random, Spangler Effect, and and others are great YouTube channels that can provide maker projects and experiments that are fun and exciting. Discovery, Pinterest, and History Channel are all great websites to use for science information or projects and concepts. There are also some great loot boxes that can provide useful tools and challenges for students. Tinker Crate, Curiosity Box, and the Action Lab box are great examples of these. To meet all of the expectations for technology, I have 3 things I would like to focus on: prep, plan, and modify. I want to plan out my experiments, labs, and projects in the summer. This will give me a chance to organize what materials I need and what I have access to. Then I can plan each project, lab, or experiment out. Then as the year goes by, I realize things will change and I'll have to modify those plans in some way. So I want to make sure that these plans are flexible and able to adapt to most situations, like students being sick or absent. To make sure I'm successful integrating technology in the classroom, I want to make sure I have a plan. I need to prep my classroom as well as take account of all the tools I have at hand. When I know what tech I have on hand, it'll be easier to implement in my lessons. These are the cited sources. Thank you very much for watching my slideshow and Panopto presentation, and have a nice day.